Chapter 2.10, Percent of Change. Our objective for today is to find percent change. And also to be able to find relative error in measurements. So your formula for percent change is going to be amount of increase or decrease. So to do that, all you're going to do is subtract, and then you're going to divide it by the original amount. I also would say biggest minus smallest divided by original. That's an easy way for me to remember it. Okay, example 1. A coat is on sale. The original price of the coat is $82. The sale price of the coat is $74.50. What is the discount expressed as percent change? So our percent change is going to be biggest minus smallest divided by original, 82. The difference is 7.5 or $7.50. Then you need to divide it by 82 and you get 0.09. You need to change that to a percent, so you're going to move your decimal 2 places to the right. Change it to 9% and look at your original. I started at 82 and I went down to 74.50, so this is going to be percent decrease. Always pay attention to what you're doing. Guided practice number 1, I want you to do biggest minus smallest, 4.1 minus 2.8 divided by original, 4.1. Do that and tell me your percent decrease. Okay, 4.1 minus 2.8 is 1.3. If you divide that by 4.1, you get 0.32. And I'm going to change that to approximately equal to because I had to round, which is going to give me 32% decrease. Obviously, if it's a decrease and you put increase, it's going to be a wrong answer. I don't care if the percent is right. Now let's find percent increase, which is the exact same thing, except this time our numbers are going up, not down. So I start at 295 and I go to 340. So I'm going to do 340 minus 295 because I always do biggest minus smallest. And then divide by the original, which is 295. I get 45 up top when I do my subtraction over 295. And when I divide, I get 0.15, which we need to change to a percent, so that's going to be 15. And I went up, so that's going to be an increase. Example 4, finding percent error. A decorator estimates that a rectangular rug is 5 feet by 8 feet. The rug is actually 4 feet by 8 feet. What is the percent error in the estimated area? Well, to find percent error, you use the formula that the error equals absolute value of estimate minus actual. So the estimated measurement minus the actual measurement divided by the actual measurement. So ours is going to be absolute value of 5 times 8, because it tells you that 5 times 8 is the estimate, minus 4 times 8, because it's actually 4 times 8, all over 4 times 8. That gives me 40 minus 32 in absolute value over 32. 40 minus 32 is 8. 8 over 32 is 0.25. So my percent error is 25%. I'm going to do guided practice number 3 with you. You think that the distance between your house and a friend's house is 5.5 miles. The actual distance is 4.75 miles. What is the percent error in your estimation? So again, our error is going to be the estimate, the absolute value of the estimate minus the actual over the actual. For this one, that's going to be absolute value of 5.5 minus 4.75, all divided by 4.75. So we'll do 5.5 minus 4.75. That gives us 0.75 over 4.75. When you divide, you get approximately 0.16, which decimal form is going to be 16% error. You are framing a poster and measure the length of the poster as 18.5 inches to the nearest half inch. What are the minimum and maximum possible lengths of the poster? When you're trying to find minimum and maximum dimensions, what you want to do is find the error they give you. So I've got to the nearest half inch. What you want to do is take your error, and that gives you, if you'll half your error, 0.5 divided by 2, you get 0.25. That's your greatest possible error in either direction. So if I've got 18.5, I'm going to take my measurement and I'm going to add the 0.25, and that gives me 18.75. When I add, that's my maximum. Then I'm going to take 18.5 and subtract my error. That's going to give me my minimum. Again, guided practice number 4. A student's height is measured as 66 inches to the nearest inch. What are the student's minimum and maximum possible heights? So if my error is to the nearest inch, 1 inch, my greatest possible error in either direction is a ½ inch. Greatest possible error. This is what you're going to add to find the maximum and subtract to find the minimum. So we'll take 66 inches. We'll add a ½ inch. We get 66.5 inches. That's your maximum. When you add, you get your maximum. When you subtract, you get your minimum. That's all you have to do. Okay, greatest possible percent error. The diagram at the right shows the dimensions of a gift box. I have to show that for you. To the nearest inch. What is the greatest possible percent error in calculating the volume of the gift box? So I've drawn the box for you. Your dimensions are height is 5 inches, width is 6 inches, and length is 12 inches. To find our greatest possible error, first we have to find our minimum and maximum volumes. So our measured volume is going to be, since volume equals length times width times height, it's going to be 12 times 6 times 5, which happens to be 360. Now we need to find our minimum. You'll remember that to find your minimum measurements, you take what your error is and half it to find your greatest possible error, and this time it's going to be a 1/2 inch. So I need to, for my minimum, I need to subtract a 1/2 inch from each measurement. So that's going to be 11.5 times 5.5 times 4.5. When you multiply all of that out, you get 284.625. To find my maximum, I'm going to add a 1/2 inch to every measurement. So that's going to be 12.5 times 6.5 times 5.5. That gives me 446.875. Okay, now I'm going to find greatest possible error, percent error. So what I need to do is take the difference between the actual volume and the minimum volume, the actual volume and the maximum volume. So first I'll do 360 minus 284.625, and I get 75.375. Then I'll take actual volume minus maximum volume, 446.875, and I get 86.875. I'm forgetting to tell you that you're taking the absolute value of it. If you'll go back to the other slides, you'll see that you're supposed to take the absolute value. Then, now you'll need to take the greater of the two, which happens to be 86.875, because we're trying to find greatest possible percent error, so we'll take the greater one, 86.875, divide it by the measured, which is 360, and we'll get a decimal, 0.24. We're rounding, so we'll make it approximately 0.24, which happens to be 24%. So my greatest possible percent error is 24%. Okay, I want you to pause the video, do these two questions on your own. Do not just write down the answer, and do not copy an answer from someone else. Do these for yourself. Bring them to me tomorrow as proof you watched the video.